Galileo Galilei, a name synonymous with scientific revolution, was born on February 15, 1564, in the bustling city of Pisa, Italy. His early life unfolded against the vibrant backdrop of the late Renaissance, a period of profound intellectual and artistic awakening. His father, Vincenzo Galilei, was a renowned lutenist, composer, and music theorist whose empirical approach to acoustics would profoundly influence young Galileo's own scientific methodology. This intellectual household fostered a keen sense of inquiry. In 1581, at the age of 17, Galileo enrolled at the University of Pisa, initially to study medicine, a path his father hoped would lead to financial stability. However, his true passion soon gravitated towards mathematics and natural philosophy. It was during this time that he encountered Ostilio Ricci, a mathematician and tutor to the Grand Duke of Tuscany, who introduced Galileo to the works of Euclid and Archimedes. Ricci's influence was pivotal, shifting Galileo's focus entirely to mathematics. Despite his burgeoning intellectual pursuits, Galileo left the University of Pisa in 1585 without earning a degree, primarily due to financial constraints. He spent several years tutoring and conducting independent studies, deepening his understanding of mechanics.
His talent was undeniable, and in 1589, he secured a professorship of mathematics at the University of Pisa. During this period, he conducted experiments on falling objects, challenging Aristotelian physics.
He also wrote De Motu, an unpublished treatise exploring the principles of hydrostatic balance and the motion of floating bodies, laying early groundwork for his later, more famous works. In 1592, Galileo moved to the University of Padua, where he would remain for 18 years, a period he later described as the happiest of his life. Here, he taught geometry, mechanics, and astronomy. His lectures were immensely popular, attracting students from across Europe. He also took on private tutoring, further expanding his influence and intellectual network.
It was in Padua that Galileo's experimental work truly flourished. He conducted extensive studies on the pendulum, observing its isochronism, the property that its period of swing is independent of its amplitude.
These observations were crucial, foreshadowing his later laws of motion and contributing significantly to the development of accurate timekeeping devices. His meticulous approach to experimentation became a hallmark of his scientific method. In 1597, Galileo invented the geometric and military compass, a versatile instrument used for various calculations, including gunnery and surveying. This invention brought him considerable income and recognition. The year 1609 marked a turning point. Galileo heard rumors of a Dutch invention, a device that made distant objects appear closer. Intrigued, he set about building his own version, without ever having seen the original. Through careful experimentation and superior craftsmanship, Galileo constructed a telescope far more powerful than any before it. His initial design magnified objects 3 times, but he quickly improved it to achieve a magnification of 20 times. This groundbreaking instrument allowed him to turn his gaze skyward, revealing wonders previously unseen by human eyes. His observations would soon revolutionize humanity's understanding of the cosmos. With his telescope, Galileo made astonishing discoveries. He observed the mountainous surface of the moon, challenging the prevailing belief in a perfectly smooth celestial sphere. He also discovered 4 celestial bodies orbiting Jupiter, which he named the Medicean stars, now known as the Galilean moons. This provided compelling evidence against the geocentric model of the universe. These early years, from his birth in Pisa to his groundbreaking telescopic observations in Padua, laid the essential groundwork for Galileo's monumental contributions to science. His relentless curiosity and empirical rigor set the stage for a new era of scientific inquiry. His foundational work in mechanics, astronomy, and the development of scientific instruments not only cemented his place in history, but also profoundly influenced the scientific method itself. This was just the beginning of his extraordinary journey. His early life and discoveries were a testament to the power of observation and experimentation, forever changing how humanity viewed its place in the cosmos. Join us in the next part as we explore the challenges and triumphs of his later years.
Building on his early innovations from the late 16th century, Galileo Galilei's meticulous observations using his self-improved telescope in the early 17th century profoundly revolutionized the field of astronomy and fundamentally transformed our understanding of the vast cosmos. His groundbreaking work, meticulously detailed in his landmark 1610 publication titled Sidereus Nuncius, or Starry Messenger, unveiled a universe far more complex and dynamic than the simple model previously imagined by scholars. Through his significantly improved telescope with higher magnification, Galileo made a series of astonishing discoveries, most notably identifying the four largest moons, Io, Europa, Ganymede, and Callisto, orbiting Jupiter, now collectively known as the Galilean moons. These pivotal observations provided compelling empirical evidence against the long-held geocentric model advocated by Ptolemy, which erroneously placed Earth motionless at the center of the universe. In 1610, following these discoveries, Galileo relocated to Florence under the generous patronage of the powerful Medici family, marking a crucial period that supported his continued astronomical research and active public engagement with scientific ideas. Galileo's studies soon extended to the observation and documentation of sunspots, which he first noted in 1611, leading to a notable and heated debate with the Jesuit astronomer Christoph Scheiner regarding their true nature and origin. Galileo's careful observations of the phases of Venus, crescent, quarter, gibbous, and full, provided further irrefutable support for the heliocentric theory proposed by Copernicus, as these phases could only be explained by Venus orbiting the Sun rather than Earth. His detailed letters on sunspots, published in 1613, openly and boldly supported the Copernican heliocentric view, directly challenging the established Aristotelian natural philosophy and Ptolemaic astronomical doctrines of the time. By 1615, Galileo's increasingly vocal and public support for the ideas of Nicholas Copernicus began to attract significant scrutiny from the Catholic Church authorities, ultimately culminating in a formal injunction or warning against teaching heliocentrism. Undeterred by these warnings, Galileo persisted in his scientific pursuits, culminating in his most famous and controversial work, the Dialogue Concerning the Two Chief World Systems, which was published in 1632 despite growing opposition. This influential book, structured as an engaging dialogue between three fictional characters, Salviati, Segreto, and Simplicio, presented balanced arguments for both the geocentric Ptolemaic and heliocentric Copernican models, though it clearly favored and advocated for the latter. The publication of the dialogue was perceived by church officials as a direct and provocative challenge to their doctrinal authority and their interpretation of Scripture, especially passages seemingly supporting an immobile Earth. In 1633, Galileo was formally summoned before the dreaded Roman Inquisition in a highly publicized trial that would forever mark both his personal life and the broader history of science and religion. Under the severe threat of torture during the Inquisition proceedings, Galileo was coerced into publicly recanting his belief in the Copernican theory, representing a moment of profound personal anguish and intellectual compromise. Following his conviction on charges of heresy, Galileo was sentenced to indefinite house arrest, spending the final years of his life confined to his modest villa in Arcetri, just outside Florence, under constant church supervision. Even during his confinement, and despite his progressively failing eyesight due to age and illness, Galileo remarkably continued his scholarly work, completing his final major treatise, Discourses and Mathematical Demonstrations Relating to Two New Sciences in 1638, a foundational text for modern physics. Galileo Galilei passed away quietly on January 8, 1642, in his Arcetri villa, leaving behind an unparalleled and enduring legacy that profoundly reshaped the course of scientific inquiry for generations. Among his many contributions, Galileo advanced the revolutionary experimental method, placing unprecedented emphasis on precise observation, quantitative measurement, and repeatable experimentation as the cornerstone of modern scientific practice. He also laid the essential groundwork for the field of kinematics, the mathematical study of motion without regard to forces, and fundamentally challenged and overturned the long-standing Aristotelian view of physics that had dominated for over a millennium. Galileo's unwavering commitment to empirical evidence gathered through direct observation, combined with his courageous pursuit of scientific truth even in the face of immense institutional adversity, continue to inspire scientists and thinkers worldwide today. His pioneering work endures as truly foundational to modern science, marking a pivotal and irreversible transition from ancient speculative philosophy to rigorous, systematic empirical investigation of the natural world. Ultimately, Galileo Galilei's enduring legacy lies not only in his specific astronomical discoveries, but also in establishing a bold new paradigm for understanding the natural world, forever altering humanity's perception of its place within the immense cosmos.